Hello and welcome back to Master Tech, and in today's video we're going to continue our controls and automation tutorial series by introducing the concept of a historian or a continuous trending tool, as well as SQL, which is kind of a more conventional database tool. So by far these are the two most common ways that data gets represented in the world of industrial automation and controls. SQL stands for Structured Query Language. There are ample tutorials on the internet on how to get started with SQL, but specifically how to embed it within like a controls and automation project is very much like an automation concept. And then historians are sort of the standard for continuous trending of automation data. So if you are just watching this video on its own, it will stand alone as a tutorial on how to use both the historian tool and create a SQL query from Ignition, which I think is useful on its own. But if you've been following along with the tutorial series, you know that we physically have this Arduino IDE PLC. We have the button and the blue light and the green light and the red light all tied to the HMI on Ignition, and then as well as input 8 there in the top right corner, which I have a physical hand switch for. So when I make the hand switch, we can see that input 8 goes on. So in the last video, we kind of introduced sequential programming, and we made this sequence where we could start, we could wait to see that hand switch go high, and then we start a timer that's going to count to a set point that we can adjust, and then we need to click this button until we get to a target value, and then we press stop. Okay, so I have a sequence. If you don't want to follow along exactly with my example, that's okay, but you should have something sequential that you want to track if you want this to be like a practical hands-on example for you. So we're using Ignition for Makers, which is a very popular SCADA supervisory control and data acquisition software. We're using Ignition Maker Edition, which is an awesome free tool that Inductive Automation put out. We have a basic HMI project that shows some of our tags, and then we have the Arduino IDE PLC sharing data with Modbus TCP data. So we're going to go into the designer of Ignition, and we're going to take a look first at a very simple continuous trend. So one thing to note is when you start storing data, when you start looking at data history over time, you need some version of a database to store that in. One really nice feature of Ignition for Makers and the industrial version of it is it'll by default have a sample SQLite database enabled, and it'll use some of the storage of your computer by default because SQLite is just a file. So it's a way of storing data that looks like, you know, Microsoft SQL or any other sort of like table and columns and rows version of SQL. But SQLite is just a file. So by default, we don't have to do anything special in Ignition. We have one connection to a database, and it's a sample SQLite database. That's really important because anytime you want to store data, you have to store it somewhere. Okay, now let's go ahead and just pull up the HMI that we were developing before. It's kind of just a little square here, and I had it mode fixed. So what I'm going to do is zoom out a little bit and widen it to be a little closer to the width of the screen. I'm going to hit save, and then I'm going to do one thing here. I'm going to change mode from fixed to %. So now it should scale with the screen. Before we did that, if we were zooming in and zooming out, all those objects would also be zooming in and out, but now it's scaled to always be full screen. So it's just a little feature of Ignition in particular. But that also means if we want to add a trend over here, we can. So if we hit the perspective components palette over on the right, I'm just going to grab a power chart, and I'm going to drag it onto the screen. And what's really cool is you don't have to tell it what tag to look at or anything. You just drag this power chart onto the screen, and Ignition has a pre-built object that will let you browse tags within that. So just by hitting save and going back to the web page, you can see this chart is on screen. The only problem is there's only example data in here. So I have tags that I added before for testing, and then they give you these sample tags of realistic values to show you what navigating it looks like. But since in the designer we haven't added historical data to any tags, we're not seeing anything, okay? So if you've been following along with the tutorials, you should have the same tags, but if you don't, that's okay. I don't have data trending enabled on any of these tags, so let's grab a few that we might want to historize. So sequence step is a good one to start with as an example. If I want to see the sequence step over time, that would tell me where in the sequence it was over time. And all I have to do when I open the tag editor is go to history and then true, and then I need to give it a storage provider, which in this case will make that sample SQLite database. And then there's a few important things here. There's deadbands, there's deadband styles. You can leave most of these on the default and it'll just start working if all you do is enable history and give it a storage provider and hit apply. It's important, I think, to call out on change versus periodic, because on change by default will only store new values when the value changes. That's kind of like a memory optimization, but you can tell it no matter what, I want it to store at a certain periodic interval as well. So we'll leave it as on change, and I'm going to hit apply and OK. And so now it should have history enabled. And let's go to that web page and let's open the tag browser. And let's browse through this to default, and then sequence tags, and then sequence step, and let's add that selected tag here. So if I collapse the tag browser, what you can hopefully see, although it might be hard on the recording, and we can click this Xtrace tool which tells us the value, we can see that sequence step is a constant 0. And if I change my real-time value to show the last 5 minutes and hit apply, and you can always edit that here in the set date range. But if I show the last 5 minutes, now let's go ahead and start that sequence, and I hit start, and it should go to step 1. And you can see this trend jumped right to 1 in real time. Now it's waiting to see input 8 transition high, so I'll go ahead and turn that hand switch, and you can see the value jumps up to 2 right away. Now it hits our 5-second timer, and it jumps up to 3. Now it's waiting for the pushes to reach the set point. 1, 2, 3. Should jump up to 5. And then if I hit the stop button, the sequence step goes back to 0. So it's really cool. You can see just right there us stepping through the sequence. So if I were to go to time set point 10 now, and we did it one more time, kind of as fast as we can here, hit start, turn the set point on, and then it's going to take 10 seconds. And then we count up to 3. And then we hit stop. But what's cool is you can see between those two runs, step 2, which is the time-based step, was 5 seconds here and was 10 seconds here. And we can narrow that window as well. We can say last 2 minutes, and you get a more precise graph going. Okay, so that's going to do it for our very basic introduction to the historian, because that is objectively the simpler of the data tracking tools that we're trying to cover today. Kind of like I said in the outset, when you just want to see process data continuously over time, a historian tool is great for that and is plenty to do that. But when you want to create a more, I guess, logical data story over time, and you want to tie what time I started, what time I stopped with, what were these settings at that time, who was doing that work, that's usually when you want to go to something like a SQL database. And like I said, we have a SQLite already here in Ignition. Again, if you're not using the Ignition platform, I guarantee your SCADA supports some way of interfacing with a database like a SQL tool. You just have to do a little reading on how to connect insert name of your SCADA or HMI platform to SQL, and I guarantee someone's done it. All right, so from the Ignition Designer, I'm going to go ahead and go to the database query browser. And I previously had a sequence data table while I was testing. I'm going to go ahead and delete that real quick with this drop table command so that we can rebuild it from scratch. So I had sequence data, I just deleted it there, so you guys can follow the exact steps that I do. So I'm going to kind of think about our sequence real quick and the things that I would want to add to capture how the sequence was running. So I would want to capture the time it started. I'll call that start time. I would want to capture end time. I want to capture what the time delay set point was and the count set point were. And then potentially a username if someone was logged in. And then maybe like a run count, an ID that says, hey, this was run 1, 2, 3, 4, 5, 6, and it just keeps incrementing up, okay? So I don't have all of those variables defined yet, but I have many of them. We're not going to worry about the tags existing yet. We're going to make that table first. So let's go back into our tools and let's go into our database query browser and let's create a table in the query browser that's going to have that data that we want. So to do this, we're going to say create table. And at this point, you guys have probably seen Ignition can use Python in some places. It has specific Ignition syntax for certain things. This is SQL syntax, and in particular SQLite, but all SQL is pretty similar if you know what you're looking at. So we're going to create a table. We'll call it sequence data, and we'll expand these parentheses out. And we'll have a field called run count, and we'll make that an integer. And we'll make this the primary key. So you don't have to know about keys and primary keys and stuff to build a simple table. You don't have to include that primary key bit. But if you want something that is like unique for a table, which would be a primary key, you're saying, hey, run can never repeat itself. If I already did run 1 or run 2 or run 3, I can't have another run 1 or run 2 or run 3. That's going to corrupt my data. So you can make that a primary key. And then we'll have a username, which we'll make a varchar50. If you haven't seen that format before, that's SQL's way of saying it could be a string. Varchar means variable character, and you can basically pass anything in there. Okay, and then we'll say start, date, time. And the reason I'm putting null at the end is kind of SQL's format for saying, do you want that field to be able to be left empty or not? And in my case, I'm actually okay if any of these fields get left empty except for the run count, because I'm sort of just trying to prove out the function. But a lot of the times you might say, hey, a row of data is going to be useless if I don't have start time or end time or a username. And in that case, you would say not null. Click count, int, null. Okay, so what I am doing right here with this command is creating a table that has an integer for run count, a string variable character for username, a date time parameter for start time and end time, and then I'm going to store the set points for time delay and click count. And if I hit execute on this, and then I refresh my little browser over here in the right, you can see sequence data has those 6 columns. And a statement that we'll use a few times is I'm going to select all by using the star from sequence data. Okay, and if I hit execute, you can see nothing exists in there. And that's actually what we expect. We expect nothing because we just made that table. So we're going to go ahead and close this. And what we're going to do next is take a look at from Ignition, from our sequence, how to store that data, how to trigger events in our Ignition sequence that are going to write data to SQL, and that'll give you an example of how to store batch data out of a sequence that you might have written in the PLC and are monitoring from an HMI. So very cool interconnected automation and controls concepts going on here. And to do this, we're going to add a few new tags. So we had our original Arduino tags from our first example of tying Arduino into Ignition. We had our sequence tags from our additional sequence. We're going to make a few new tags just so we can keep track of when we added what. So we're going to make a new folder called SQL tags, and I accidentally added it inside that folder. Let's go ahead and liberate it. And we need to add a few new tags. One of the first tags is going to be a new standard tag. I'm going to make it a memory tag, and I'm just going to call it run count. Okay, and we're going to leave it in the default tag group. It's going to be memory, it's going to be integer, and to start, it'll be a 0. Okay, so the run count is going to be that primary key that tells us how many times we've run through this sequence. And we're going to make another new tag, standard tag, memory tag, and this one we'll call username. Okay, so if you were going to log in, you could store that info in a string tag. Initially, we'll say it's Pete. That sounds like a cool guy. And then the last new tags that we have to create are start time and end time. So I'm going to do new standard tag, memory tag. This format is going to be date time, and we'll call this start time. And actually, getting a little bit ahead of ourselves here, but I'm going to only make start time, and we're not going to need a tag for end time because we're going to use the trigger event that finishes the sequence as the time to go do end time. All right, so there's just me adding the tags that round out what we're going to write to SQL because everything else already existed. Let's capture the start time of our sequence. So when we click this button for start and we're in step 0, that's when we go from step 0 to step 1. So I'm going to click on the sequence step tag, and I'm going to go to scripting, and I'm going to go to value change, and I'm going to add a little if current value dot value is equal to 1 and previous value dot value was equal to 0. So here I'm taking advantage of the tag change event, which has current value and previous value as parameters of the event. And technically this sequence only ever goes to step 1 from step 0. So this is kind of an over-engineered statement, but we're going to leave it. And I'm going to say, okay, that means someone just started up the sequence. So I'm going to system.tag.write blocking, which is the ignition syntax for writing a value to a table. And I'm going to copy the path for that start time tag that I just made, copy path. And I'm going to paste that path in here. And then I'm just going to say use system.date.now. Okay, so this is Ignition's like system formatted. Go grab a timestamp of what my computer says it currently is and store that in a tag. And I'm going to hit apply, and I'm going to hit OK. And I'm going to hit save. And now we're going to go back here and we're going to hit start real quick. And now we're in step 1. And if we go back into the designer, now we can see we have, August 12th at 10:17 p.m. stored in start time. So that's cool. That tells us that our script worked. Now we've got the time capturing into start time, which is very cool. But to actually write to SQL, we need to hit a database, which is technically a gateway scoped thing. So we're going to go to gateway tag change events, and we're going to go to tag change, and we're going to create a new event, and we're going to call it write to SQL. But basically we're going to say when that sequence step tag changes, when the value specifically changes, so not the quality, not the timestamp, but the value of that tag changes, we're going to trigger this write to SQL script. But we don't want to trigger that script every time the value changes, only when it resets. So we're going to start by doing system.tag.read blocking on that sequence step, and then square bracket 0.value. That's just a little Ignition specific syntax for how to read the value out of a tag. And we're specifically going to say if value equals 0. Because value equaling 0 means that the sequence has just reset. This is an on tag change event script. So the tag is only changing to 0 when someone hits stop because it was in sequence step 5. So that's when we're actually going to trigger write data to SQL. Now, all we really need to do is we need to go out and read all tags that have SQL data. And then we're going to do a section of define the SQL query and arguments. And then we're going to call the SQL query and increment the counter. So if you remember, we have like a counter variable. It's currently at 0, and we're going to increment that every time we do a new run. Okay, so these are kind of the 3 sections we have to create in this script, and it's immediately, hopefully, sort of apparent why you don't want to do this just on a tag change script. It's a little bit easier with gateway events to keep revision control and sight on things like that. So we're going to read all the tags that have SQL data. And if we remember our table, we want to start with start time. And I'm going to try to keep the convention, of first letter lowercase and then all following words. What is that called? Snake case, I think, or camel case. I get the 2 backwards. Okay, in any case, we need start time, we need end time, we need the username, we need the count set point, we need the time delay set point, And we need the run count, that unique parameter. So we need to read all these tags. I'm going to steal this system.tag.read blocking command here. And I'm going to just replace the tags. So start time is going to be that start time tag, copy path, and paste it in here instead. And then actually that isn't what we want it to be for end time. We want system dot date dot no system dot time dot now. No, system dot date dot now. Come on, Pete, getting tired. So we want system.date.now for end time, and then for the username, that's going to be, we're going to copy this line and look at username instead of start time. So we're just going to update this bit to username. And to write basically all we're trying to do, just to be super clear, is that when we write a SQL query, we need to pass in all of the data we want stored in SQL. So within our script, we have to go out and grab the data that we want it to read. You can read all of these tags in one line of code. I think it's a little easier for beginners to see it broken out this way. So let's go ahead and say run count is this, just run count like that. And then time delay set point is actually copy path in a little bit of a different location. So we'll copy that one. And then count set point is right next to time delay set point, but it's called HMI underscore count SP. Okay. So that should give us the 6 fields that we want to write into SQL. One thing that is worth calling out, so we've got start time. We're actually going to format start time here. We're going to use a command called system.date.format because the ignition date and what MySQL or SQLite uses are slightly different. So we're going to take that start time and we're going to explicitly tell it to be 4-digit year with YYYY, 2-digit month, 2-digit day, and then 2-digit hour, 2-digit minute, and then 2-digit second. So we're explicitly defining a date format because SQL will throw an alarm, throw an error if it uses the exact ignition format. So we're going to make this new variable start and end instead of start time and end time. And they're just going to have the transform data. You can do system.date format and system.tag reblocking on the same line. I think it's easier to split it out this way, especially for beginners. But if you look at this tag, and if you were to see that printed, it's got PM on it, and it can also, depending on the ignition statement, it can sometimes have the date too, like it'll say Monday, the whatever. So this is just us explicitly calling out a format that we know SQL will support. Okay, so we've got all of the raw data we need. Now we're going to define a query. And this is a cool thing about Ignition. You can just write simple queries in a string of text. This is true of Python as well. If you're a bit of a Python programmer, we can just type in insert into sequence data, and we can say username. Let's go real quick to the database browser, query browser, and make sure I get all these column names right. Whoops, where'd they go? Yeah, so we've got run count. I'm just going to take a snip of this real quick. Run count. No, I'm going to leave it up the whole time, even better. Gateway events. Okay, so we want username like that. So this is case sensitive, which is the main reason I'm being extra careful about this. Oh, where'd my gateway event go? And we're going to insert using. Now the order also doesn't really matter. It's okay that we grabbed the order in a different, grab these raw tags in a different order that I'm defining them right here. Click count. What else did we have? Let's just finish typing these in so that then I can talk. Time delay, start time, and end time. Okay, what I was trying to say is it's okay that these are in different orders because then we say the values are going to be parameters that we pass in. So we do that with these question marks. So there should be 6 parameters that we're passing in. So our SQL statement is just saying we're going to insert values into those 6 columns, and the values are things we're going to pass in. They're going to be arguments. So args is equal to, and then a square bracket. And here I'm going to do a little typecasting. I'm going to say, okay, string username. It's never a bad idea, even if you're pretty sure it's already the right format, to explicitly make sure that it gets defined as the right format. So like run count needs to be an integer for it to work. Click count, same deal, which what do we call click count? Count set point. Count set point. And then we have the time delay set point, same thing, that needs to be an integer, time delay SP. And then we have our start time and our end time. And actually for another just my SQLite thing that I'm sharing with you all is that casting it to a string in the correct format is the best way to ensure that it gets stored in SQLite appropriately. So there's a little bit of just knowing how to play the game here. But basically what we've done is we've said username, run count, click count, time delay, start time, end time are going to be passed in as 6 parameters. That's what the question marks mean. And then this order is very important. These need to correlate to the column order that you just did. So it needs to be username, run count, click count, time delay, start time, end time. Now there's only 2 lines of code left and then we're done. We want to do system.db.run prep update, and we're going to pass in the query and we're going to pass in the arguments, and then I'm going to delete out all the other auto-generated stuff. System.db.run prep update, query, and the arguments. And then the last thing I want to do, which will also show us when we run it that it's working, is I want to do system.tag.write blocking, and I want to write to the count set point, no, run count. I want to write to this tag, a value of run count plus 1. Okay, so this is me saying, hey, at the very end of logging data to SQL, I want to increment the run count parameter by 1. Okay, so we're going to go ahead and hit save, and to see if it's working, we're going to go ahead and run through the sequence. So, all right, let's count up 1, 2, 3. Now it's in step 4. Let's go ahead and hit stop. Okay, now it's idle, it's ready to go again. Let's go ahead and go back to the designer, and you can see run count is 1. So if you weren't looking before, it was 0. To make sure that it actually got to SQL, we'll go to Tools, we'll go to Query Browser, and again, we'll go ahead and select all from sequence data like we did before, hit execute, and that's pretty cool. Now we have run count, username Pete, start time, end time look accurate. I had a pretty big break between when we started and now. The time delay set point and the click count. Okay, so let's go ahead and go back there one more time. Let's say now the count set point is only going to be 2, but our time delay is going to be 5 seconds. And in the designer, you could make it a label on the field, but in the designer, I'm just going to change the username from Pete to Peter. And let's go ahead and start this thing again. So start, and waiting to see input 8. There we go. Time set point, count up to 5. Count set point, count up to 2. And press stop. Okay, so back to designer we go. And now we can see run count is up to 2. We go ahead and we go to the query browser and we search again. We have 2 entries. So one last thing, because it's nice to tie it back into a visualization. In SQL tags, we're going to add a new tag and a new standard tag and a query tag. And we're just going to say SQL results. I'm trying to go pretty fast now because I know how long this tutorial's gotten. And we're going to make this a query tag. We're going to make it a data set. Data set, I know you're in here. There it is. And we're going to just make it every, let's say 10 seconds. No, 5 seconds. What the heck? It's not doing much. We're going to make a query that is just going to be select all from sequence data, just like we've been running. And the data source is going to be our SQLite database. I'm going to hit apply. And now I'm going to drag that SQL results onto the screen, and I'm going to make it a table. And one Ignition thing, I've seen a lot of forums, a lot of people are like, why do my dates look jacked up? This is just a little bonus lesson for you. When you have a table, you need to explicitly define the columns are date time to get the date and time to look correct. So if we go to columns in the table and we add array elements and we say 1, 2, 3, 4, 5, and 6, we can go to 2 and 3, which in this case are start time and end time, and we can say start time, and then you come down to date format, date time, and there you go. Start time looks good. We can do the same thing, go to 3, end time. This very much is a tidbit of useful if you're working in Ignition. No other SCADA that I've seen has this like explicitly needing to define dates and times. But we're not going to worry about that. We have a table on the screen. Let's go ahead and run it one more time so you guys can see this power of live updating. So we're going to start it again. Let's change this to 6 and this to 4 and transition the hand switch. We've got to wait 6 seconds. So we should have one now that shows starting after this 2303. 1, 2, 3, 4, and push stop. And within 5 seconds, this table here should update. There you go. It's way less than 5 seconds. New start time, new end time, new time delay, new click count. Okay, so we've seen just in a couple minutes, we've seen how quick and easy it is with a good SCADA software to be able to monitor live data. This same tool can go back in history pretty far, so you can look at days or weeks past as long as your computer's retaining it. And you can look at continuous trending data like that. You can look at SQL data like that. Far and away, Historian and SQL are the two most powerful data analysis tools for automation and controls engineers to get familiar with. So I hope you found this to be a useful introduction. I hope you have found the introduction to the automation and controls tutorial series, if you've been following the whole series, to be super useful. We've covered the majority of the basics to the point where you should at least understand the major fields that we're addressing. And so the next big video on the channel is going to be a large build where we combine all of these concepts together as a kind of tutorial and showcase of the skills that we've developed together. So as always, if you have any questions about what you saw in this video today or things you'd like to see in the future on the channel, be sure to let me know about them in the comments below. Thank you so much for watching, and we'll see you next time. Thanks, bye.